In this lecture, you're going to learn about the three main types of traffic that we'll send over an IP network, which are unicast, broadcast, and multicast. Unicast traffic goes to a single destination host. Broadcast traffic goes to all hosts on the subnet, and multicast traffic goes to multiple interested hosts. So let's have a look and see how this works. So the first example here is going to be unicast traffic. I've got the sender over on the left, and it sends some particular traffic to the PC up at the top of the picture there. And it also sends some other traffic to the PC up at the top right. So unicast traffic, it's coming from a sender and it's going to one particular host, so unicast. The next traffic type is broadcast traffic. So with broadcast traffic, the sender sends one copy of the traffic that will come into the switch, and then it gets flooded out to all other hosts on that particular part of the network. So you see here, it goes to all of the different PCs that are attached to the switch. There's only one copy of the traffic that gets sent everywhere. You'll see it also hits the router in the middle there, which has got an interface, which is on that network. What happens then is the router will drop the traffic. So routers do not forward broadcast traffic on. You see the other two interfaces on the router, we don't forward the broadcast traffic out the other side of the router. This is a good thing because if you think about it, like with the internet, imagine if you sent out broadcast traffic and it got sent to everybody on the internet. Well, there's a lot of broadcast traffic, and that would really badly affect performance, and also we could say there's security concerns there as well. So broadcast traffic, one copy gets flooded everywhere throughout that particular part of the network. The next traffic type we're going to cover is multicast, but I want to just mention about how unicast traffic works to multiple hosts first, because this is going to help you understand why we have multicast traffic. So let's say the sender over on the left, it's going to stream out some video traffic, and let's say the bandwidth of the video stream is 1 megabytes. So it sends it to the PC at the top. It also sends it to the PC up at the top right, and it's sending separate copies of the same traffic to each of those individual hosts. It also sends it to the PC over in the middle on the right as well. So we're sending a video stream, it's 1 megabytes in bandwidth, we're sending 3 separate copies of it, so that would take 3 megabytes worth of bandwidth from the host over on the left, also throughout that part of the network as well. With multicast, we send one copy that goes to multiple different destinations. So you'll see how this works. Now the sender sends one copy of that same video stream, and that one copy then gets sent out to all of the interested receivers. So now, rather than sending 3 separate copies, taking up 3 meg in our example, we send one copy. It only takes up 1 meg, so we've got good bandwidth savings there, but it goes to everybody that's interested. The difference between broadcast and multicast traffic is that broadcast traffic goes to everywhere on that particular part of the network, whether the receiver has requested it or not. Multicast goes to multiple receivers, but it's targeted. They have to request it before we're going to actually get it. And a good analogy for multicast traffic is you can think of it like tuning into a radio station. So all of the different receivers, they've tuned into that particular station, they're going to get that particular traffic. Okay, that's it. That's our unicast, our broadcast, and our multicast traffic.